This is the brief on the ancient origins of musical tuning. The mathematical DNA of every song we hear today actually stems from an ancient technological arms race used to synchronize human tribes and legitimize entire empires. First, let's talk about prehistoric social glue. Around 40,000 years ago during the Ice Age, humans at Hohlefels carved incredibly precise flutes out of vulture bones. Now, why would freezing cavemen waste energy doing precise math on bird bones? Well, standard pitch wasn't about art, it was a survival mechanism. Synchronizing sounds triggered an endorphin release, acting as a social glue to unite the tribe against danger. Second, we hit an acoustic divergence. In the West, Pythagoras easily observed musical ratios just by pinching strings. But in the East, ancient China independently mapped their 12-tone scale using bamboo pitch pipes. You'd think a pipe is as easy to calculate as a string, right? No way! Bamboo creates this invisible air bulge, an aerodynamic distortion called end correction, making acoustic math inherently frustrating and inaccurate compared to a harp. Finally, we get to a Chinese mathematical miracle. To overcome that messy bamboo physics without relying on fractions, ancient scholars used an ingenious workaround called the Sanfen Suni method. They assigned their base note, the yellow bell, a massive starting integer, 177,147. Why such a crazy big number? Because it's exactly 3 to the 11th power. This let them divide by 3 exactly 11 times, generating a 12-tone scale using purely clean whole numbers. This pitch became so trusted, it was literally the imperial standard for measuring weights and volumes using millet grains. Ultimately, musical pitch isn't just about good art. It's a fundamental mathematical code that helped early humans survive the cold and ancient empires
Welcome
map
to the debate.
cosmos.
Imagine realizing that the fundamental code underlying every song you've ever heard, the mathematical DNA of music itself, didn't actually originate where history books claim it did.
Yeah, it's a pretty massive shift in how we view the ancient world.
Right, it really is. So, back in 1780, there was this Jesuit missionary in China named Joseph Amiot, and he made just a staggering claim. After he studied these ancient texts, he declared that attributing the invention of the musical scale to the ancient Greeks, specifically to Pythagoras, was an outright act of robbery.
Act of robbery. Those are strong words for a missionary.
Very strong. And that brings us to our focus today, which is Lu Shu, the ancient Chinese interdisciplinary study of musical pitch, tuning systems, and acoustics. The central question we are hashing out is, did the ancient Chinese independently invent the mathematical foundation of musical intervals? Or does the striking similarity between the Chinese 12 Lu system and Pythagorean tuning point to a shared, earlier origin in Babylonia with later cross-pollination between East and West?
Right, the diffusion theory.
Exactly. Now, my position today is that the Chinese development of the 12 Lu, which are the 12 pitches of the octave, and the mathematical algorithm used to derive them was a wholly indigenous, brilliant innovation. I argue it not only predates Pythagorean tuning, but uniquely integrates with ancient Chinese socio-political philosophy in a way that proves it was an independent, deeply cultural evolution.
Well, and I come at it from a fairly different way. While I obviously acknowledge the absolute brilliance of ancient Chinese acoustics, the technological realities of early Chinese instruments compared to the Greeks and the Babylonians, it points us in a different direction. I lean pretty heavily on the historical analysis of the great historian of science, Joseph Needham. Because when you look at the physical limitations of the bamboo pitch pipes the ancient Chinese used, and you compare that to the linear precision of stringed instruments in the West, it strongly suggests a shared Babylonian root for both tuning systems. I just don't believe in pure Chinese primacy here. I think the evidence points to a global acoustic awakening radiating out from Mesopotamia.
I hear you, but the textual and archaeological evidence strongly supports independent Chinese mastery of acoustics long before Pythagoras was even born. I mean, if we look at the text Liu Ji Chung Chu, it records the legend of Ling Lun. He was said to have created the standard pitch known as Huangzong, or the yellow bell, around 2000 BCE.
Right, but 2000 BCE is heavily shrouded in legend.
It is, I acknowledge that. But this bass pitch is effectively equivalent to our modern C note vibrating around 440 hertz, and the hard documentary evidence that follows that legend is just irrefutable. By roughly 645 BCE, the text Guanzi explicitly details the Sanfen Sunyi method.
The adding and subtracting thirds.
Exactly. It translates to 1/3 reduction and addition. This is the exact mathematical algorithm required to generate the 12 semitones of an octave. And by the 5th century BCE, the Guayu records the specific names of all 12 lu. And this wasn't merely theoretical scribbling by scholars in a room. In 1978, archaeologists excavated the tomb of Marquis Yi of Zheng and found this enormous, intricately cast bronze Bianzhong bell set. Those 65 bells definitively prove these 12 semitones were in practical, highly sophisticated use. Amiot wasn't exaggerating when he called the Western claim an act of robbery.
Look, that historical timeline is fascinating, and the bells are incredible. But have you considered the broader technological context of the ancient world? Attributing sole primacy to China ignores the realities of how acoustic mathematics actually works in the physical world.
How so?
Well, Needham's hypothesis suggests that the germ of acoustic discovery radiated east and west from Babylonia. And why Babylonia? Because they possessed highly developed stringed instruments like harps and lyres much earlier. This creates a really critical technological discrepancy.
Okay, I think I see where you're going with the strings.
Right, because the early Chinese tuning system was fundamentally based on pitch pipes, which are essentially just hollow bamboo tubes. The Greek and Babylonian systems were based on measuring string length. From a purely physical standpoint, calculating precise mathematics on a string is intuitive. Calculating it on an air column inside a bamboo pipe is incredibly complex and prone to physical distortions.
Yeah.
So this hardware difference, it strongly suggests the math originated with strings in the West and eventually influenced the East.
I see why you think that, but, well, let me give you a different perspective on the idea that they couldn't have developed it independently just because they used pipes. Assuming parallel evolution is impossible is like, it's like seeing two identical architectural arches on opposite sides of the world and assuming they were built by the exact same architect.
I don't know if that's a fair comparison.
I think it is, because it ignores the fact that universal laws of physics dictate the shape of a strong arch. The physics of sound are universal. A perfect fifth sounds harmonious to a human ear, whether that ear belongs to a Greek philosopher, a Babylonian priest, or Zhou dynasty musician.
I'm sorry, but I just don't buy that the arch analogy works here. Yes, the physics of sound are universal, obviously, but the physical tools used to measure those physics, they fundamentally change the path of discovery. Let's think about how a string actually works.
Okay, if you take a string on a Babylonian harp and you pinch it exactly in half, the frequency of the vibration doubles. You get a perfect octave.
Right.
If you pinch it at exactly 2/3 of its length, you get a perfect fifth. The mathematical ratio maps flawlessly, 1-to-1, onto the physical object. It is directly visually observable. But pitch pipes, the primary acoustic tool of ancient China, they do not behave cleanly like that at all.
Ah, you're referring to the aerodynamics inside the tube.
Exactly. There's this phenomenon in acoustics called N correction. When you blow air into a bamboo pipe, the vibrating column of air doesn't just stop neatly at the physical edge of the bamboo. It actually bulges out slightly past the open end of the tube.
The diameter of the pipe actually interferes with the effective length of the sound wave. This means you can't just take a knife, cut a bamboo pipe exactly by 1/3, and expect a mathematically perfect fifth.
Because the pitch will be off.
Right. The frequency will be flat because of that invisible bulge of air. Therefore, the reliance on pitch pipes made foundational acoustic calculations inherently frustrating and difficult. They just wouldn't have naturally stumbled upon perfect math using those specific tools.
Okay, but you are assuming the pitch pipe was their only acoustic tool, and you're completely ignoring the bronze bells I mentioned earlier. That is exactly why their achievement points to independent innovation. They didn't just stumble upon it, they overcame those physical limitations of bamboo through sheer mathematical rigor and advanced metallurgy.
Well, metallurgy, yes.
Going back to that 1978 excavation of the Bianzong Bell set, we are talking about massive, intricately cast bronze instruments from the 5th century BCE, and they were accurately tuned to the 12 lu. And here is the crucial detail about those bells.
Okay.
Each individual bell is almond-shaped, not perfectly round, and that shape allows a single bell to play 2 distinct, intentionally tuned notes depending on exactly where you strike it.
Wow. 2 notes per bell.
Exactly. And you cannot tune a bell with 2 distinct notes after it's cast by just, twisting a wooden peg like you can with a string. The 3D geometry, the mass distribution, the shape, all of it has to be mathematically perfect in the clay mold before the molten bronze is even poured.
That is impressive, I'll admit.
Right? They had to understand the theoretical acoustic math at a profoundly deep level centuries before significant cross-continental exchange could have brought Greek theories to the Chinese heartland.
But that's a compelling argument regarding their metallurgical skill, definitely. But look at how they actually wrote this acoustic math down later on. It looks suspiciously Greek. Take the Lu Shu section of Sima Shan Shiji, dating to around 145 to 89 BCE.
Okay.
When Sima Shan writes down the calculations for the 12 lu, he uses fractions. He explicitly uses the exact same fractional methodology that the Greek Pythagorean tuning system uses.
Well, math is math.
But when you have 2 disparate cultures expressing a highly complex acoustic algorithm using the exact same fractional mathematics, it stretches credulity to call it coincidence. It is highly probable that the more easily calculated method, the Western string method, was transmitted along the early Silk Road to help Chinese scholars solve those inherent physical limitations of their native pitch pipes.
That's an interesting point, though I would frame it very differently. You were looking at Sima Qian, but you were skipping right over a crucial, slightly earlier text that destroys the idea that they needed a Western rescue package of fractions.
Which text?
The Huinan Zi, which was edited between 179 and 122 BCE. It demonstrates a staggeringly sophisticated, completely independent mathematical workaround. They calculated the entire 12-tone scale without using a single fraction.
Wait. Logistically, how do you even calculate a 1/3 reduction without fractions?
It's brilliant.
I mean, the Sun-Fen-Suni method literally means reducing and adding by thirds. If I take a string or a pipe of 100 inches and I reduce it by 1/3, I'm dividing by 3. That gives me 33.333 repeating. It's an infinite, messy decimal. And you have to do this alternating sequence, up a 5th, down a 4th, 11 times to generate the whole scale. How could they possibly avoid fractions?
That is precisely the genius of what they did. They understood the decimal trap you just described perfectly. So they didn't start with an arbitrary base number like 100 or 10. They assigned the foundational pitch, the huangjang, a massive, highly specific integer. They gave it a value of 3 to the 11th power. That number is 177,147.
Let me process that for a second. 3 to the 11th. So they built the starting length entirely out of factors of 3.
Yes. By setting the starting length to 177,147, they guaranteed that they could divide the number by 3 exactly 11 times without hitting a decimal. Let's just do the first calculation.
Okay.
If you take 177,147 and divide it by 3, you get exactly 59,049. You multiply that by 2 to get your 2/3 length, which is 118,098. A perfectly clean integer.
Huh.
The addition of a third gives you another clean integer. They calculated all 12 pitches in perfectly round whole numbers. Not a single fraction, not a single decimal point. Sima Qian using fractions later was just a different stylistic representation of the same math. The Hainan Zi proves they had a native, highly advanced mastery of the arithmetic. This isn't borrowed math. This is a bespoke, elegant, indigenous solution requiring immense foresight.
Okay, I will grant you that the use of 3 to the 11th power is an absolute masterclass in arithmetic elegance. The sheer foresight to construct the scale backwards from the maximum necessary divisibility is, well, it's beautiful. But we have to ask why they went to such extreme lengths to force the math into perfect whole numbers.
Because of their worldview.
Right. For Pythagoras, numbers were the constituent elements of physical reality. But for the ancient Chinese, musical pitch carried a far heavier burden. It was the foundation of the state, the calendar, and the cosmos itself.
Precisely. And this shifts our focus from how they calculated the pitches to why they did it. The Chinese system is utterly unique because it was fully integrated into their metrology. The Shangshu, dating back to 1000 BCE, links harmonizing the calendar, standardizing weights, and standardizing measurements directly to musical pitch.
The pitch pipe wasn't just a musical instrument. It was literally the imperial standard for measurement.
Right. Look at the Emperor Wang Mang. During the Qin dynasty around 9 to 23 CE, he usurped the throne, and to legitimize his new dynasty, he used sound as the foundation for imperial standardization. But we really need to ask, why sound? Why not just carve a ruler out of stone or cast a bronze weight?
Well, because physical objects decay. They warp and they wear down over time.
Exactly. A wooden ruler shrinks in the cold. A bronze weight can corrode or be shaved down by a corrupt merchant. But the frequency of a perfect Wangzhong pitch is a universal, immutable constant. Wang Mang's ability to control and reproduce this sound was viewed as proof that he could synchronize heaven and earth. He used a single pitch pipe to set the standard measure of length, volume, and weight simultaneously.
And he did this using millet grains, right? I vaguely remember this.
Yes, millet grains. The volume of the Huangju-zhong pitch pipe was designed to hold exactly 1,200 grains of medium-sized black millet. That specific volume became the yu, the standard unit of volume for the entire empire. The weight of those 1,200 grains became the 12 zu, the standard unit of weight.
It's all interconnected.
Completely. And if you lined up 90 of those grains lengthwise, it equaled the exact length of the pitch pipe, standardizing the inch. His ruling legitimacy literally rested on a perfectly tuned pitch pipe, because sound was the most infallible truth they had.
Which is a beautiful, cohesive philosophical system. I mean, truly. But it ultimately exposes the physical tragedy of the Chinese acoustic project. And this is where the insistence on flawless Chinese primacy hits a wall of acoustic physics. You mentioned they wanted to synchronize heaven and earth.
Yes.
To do this, they mapped the 12 lu onto the 12 months of the year and the 12 double hours of the day. Because the calendar is a perfect cycle, December transitions smoothly back into January to close the loop, they expected the mathematics of sound to be a perfect cycle as well.
Ah, you're referring to the concept of Huangzhong Huanyuan, the expectation that the yellow bell returns to its original pitch.
Yes. If you start on Huangzhong, your base note, and you apply the Sanfen Sanyi method 12 times, going up a perfect fifth, down a fourth, over and over, you generate the 12 notes of the scale.
Right.
The expectation was that on the 13th calculation, you would arrive back at the exact same note you started on, just several octaves higher. The societal desire was a perfect, closed mathematical loop. But acoustic physics does not care about imperial cosmology.
No, it doesn't.
Let me break down the math of that clash really quickly. To go up a perfect octave,
You multiply the frequency by 2.
right. And to go up a perfect fifth, you multiply it by 3 over 2, or 1.5. No matter how many times you multiply 1.5 by itself, it will never exactly equal a power of 2. Mathematically, 1.5 to the 12th power is roughly 129.74.
Mm-hmm.
But 2 to the 7th power, which is 7 octaves, is exactly 128. They do not match. Stacking 12 perfect fifths mathematically overshoots the octave. The cycle simply does not close. There is a discrepancy, what the West calls the Pythagorean comma.
Right.
The 12th note is slightly sharper than the original starting note. The loop is broken. For a society that based its entire metric of political stability and calendar accuracy on the perfection of this acoustic cycle, this physical reality was a profound disruption. This is exactly why I argue the system was fighting against its own theoretical and physical limitations.
I'm not convinced by that line of reasoning, honestly, because you are framing their discovery of the comma as a philosophical failure. I view it as the ultimate proof of their scientific rigor. I completely agree with the physics you laid out. The cycle of fifths doesn't close. 129.74 does not equal 128.
Right.
But the ancient Chinese didn't just ignore this to save face cosmologically. They successfully identified, measured, and documented this exact discrepancy. They calculated this gap to be approximately 23.46 cents.
We should probably clarify what a cent is for the listener, because a number 23.46 doesn't mean much on its own.
Good idea.
In acoustics, a cent is a logarithmic unit of measure. It is exactly 1/100th of a semitone. So the distance from a C to a C sharp on a piano is exactly 100 cents.
Exactly. So they found a discrepancy of 23.46 cents, roughly a quarter of a single semitone. It is the absolute smallest comma that human beings had ever mathematically isolated at that time. They faced the acoustic reality that the universe's math is slightly asymmetrical, and their scholars meticulously calculated that minute difference rather than sweeping it under the rug.
That's a fair point.
That is the hallmark of advanced empirical science. They didn't need a Greek string to tell them the cycle didn't close. They found the comma using their own frameworks and acoustic tool.
Look, I concede that their measurement of the comma is a triumph of ancient science. I genuinely do. But we have to look at the totality of the historical timeline here. We have the Babylonians with their stringed instruments, empirically finding these same acoustic ratios centuries earlier.
Sure, earlier strings.
And we have the physical reality that string division is objectively the cleaner, more linear pathway to discovering this math than navigating the end correction aerodynamics of bamboo pipes. And we have later Chinese texts utilizing fractional math that cleanly mirrors Western models. While the application of 3 to the 11th power and the cosmological integration of the pitch pipe into Wang Mang's imperial metrology are uniquely Chinese, the underlying mathematical seed, generating the scale via perfect fifths, it just feels too universal.
Too universal?
Yeah, and too aligned with Western string physics to completely rule out Needham's hypothesis of a shared, radiating ancient origin.
I understand that perspective. I really do. But for me, the ancient Chinese Lu Shui remains a highly sophisticated, fiercely independent system. From the early legends of Ling Lun in 2000 BCE to the explicitly documented Sunfin Sun Yi method centuries before Pythagoras, the evidence of primacy is incredibly strong.
But we can't ignore the physical tools.
But more than just being first, it's about how they did it. The genius of using 3 to the 11th power to entirely avoid messy decimal fractions, the metallurgical triumph of casting precisely tuned two-tone bronze Bianzhong bells by the 5th century BCE, and the integration of the 12 lu into the standard of imperial weights and measures using millet grains. All of this shows a system mastered entirely on its own terms.
It was certainly a comprehensive system.
They didn't just find the perfect fifth. They built an entire civilization's worldview around it. And when the physics presented that 23.46 comma, they had the empirical rigor to measure it accurately.
And my perspective remains that while the Chinese achievements are staggering, particularly identifying that minuscule comma without digital technology, the instrumental reality suggests a more interconnected ancient world. The Babylonian origin theory cannot be easily dismissed. The physical evolution of acoustic discovery flows much more naturally from the linear observable math of string measurements than from the messy acoustics of pipes. It is highly probable that acoustic mathematics was a shared human pursuit, a germ of insight that traveled, adapted, and was refined by different cultures, rather than an isolated miracle in just one region.
While the fact that the pursuit of musical harmony pushed the absolute boundaries of ancient mathematics and physics in both the East and the West is something we can certainly agree on. It bridges the gap between universal physics dictating our discoveries and human ingenuity finding deeply cultural ways to decode those physics.
It truly does. And honestly, it makes you look at the keys of a piano today with a completely different kind of reverence.
Yeah, it really does.
Every time you strike a perfect fifth, you are hearing the exact mathematical tension that ancient empires built their calendars around.
It really makes you wonder, when we claim a patent on a discovery today, are we truly the first to uncover it, or are we just the loudest voices in the room, completely unaware of the quiet, complex calculations someone else was making thousands of years ago?